Hi guys, welcome to the clash detection part, and as I told you before, clash detection is one of the most important and most crucial parts of Navis. In other words, Navis is created for the clash detection. Here as you can see, I have prepared an RVT file and I'm gonna explain the topics on this file, and then for reviewing the topic we will consider all of the topics again in an actual project so that you can get familiar with everything such as the issues and topics which may occur in the actual and big projects that you want to carry it out. Well done. Here as you can see in this RVT file, I got two model geometries, I got two buildings, the original one and the copy one. Following that, I'm gonna make some changes on each of these models. After that, I'm gonna transfer these files to Navis and then check them out. Anyway, look at here. Here we got the beams, we got the long beam and their intersection with the channels and the pipes which is passing through the wall from middle of the wall. And let me open the view of level 1, and here as you can see the walls, I have overlapped some parts of the wall and there is no intersection between walls and columns. And if we check the ceiling here, the position of the columns are voided. Following that, we got some lights, but at the another model I want to make a copy from the selected wall by this way, then I paste it aligned to the same place. Note that when you copy a wall or an object and then paste it aligned to itself, the doors and the windows will be pasted aligned to the same place. Here as you can see, I got two windows. So practically here we got two walls which are overlapping each other. But in the another model geometry, let me open the plan view. Here we got two types of wall, that one of them is thicker than the other, and the thinner one is located inside the thicker wall, which is not correct, it's repetition. And at the other side, as you can see, we got a wall here as I'm showing, and at the other side I have added another wall, and this is not correct too. So I have prepared an intersection in the thickness of the wall intentionally. And what else? For example, at the another model, I want to make some copies from the beams. So first of all, I select them by this way. Check this out. And I also select the ducts. I select them, then I open filter, I uncheck all of them, then I check ducts and structural framing girder, then copy and align to same place. Following that, I'm gonna show you how to find the clashes and the intersections and duplicates in Navis. For example, here we got a duplicated wall and also duplicated beams and ducts. Then at the other geometry we got no duplicates. For example, here one of the walls is placed inside the other one, and here there is an intersection in the thickness of the wall, and at the other side there are some longitudinal intersections. There are some parts which have longitudinal intersections. Here at the beginning of the video, I'm gonna explain the type of the clashes. We will talk about the clash detection later. Here we're just gonna talk about the clashes that can occur in the construction process. At first we should get familiar with the clash detection system of Navis, and then we will move on and go through clash detection topics, and I will explain everything. Very well, here as you can see we got an RVT file here and we want to export it to Navis. As I have mentioned before many times, that you can export your Revit file directly to Navis and then open it there, and its advantage is that if you make any changes in Navis, then your RVT file or Revit file would be updated too. Or you can export your RVT file as a NWC file, as you can see, to save the scene as a NWC file and then import it to Navis, so that there is no direct connection between your RVT file, Revit, and Navis. If you make any changes in your file in Navis, Revit is not going to be updated directly, because you should export your file to Revit again and then update it there. So we're gonna have several transformation between Revit to Navis. Firstly, we export them to Navis for the clash detection, and then we should import it to Revit for the revising the conflicts. So at first we need to link Revit and Navis to each other, but as I told you before, we may not be able to link Navis and Revit in the big projects. So we have to save our file in NWC file in Revit. So no matter if you couldn't link your Navis and Revit to each other, because you can save your file as NWC and RVT to transform your file between Revit and Navis. So let me open the RVT file, but before that let me save my Revit file. I forgot to save it. I name it as Clash just for practicing. Then I open the file in Navis. I select and then click on open by this way. So wait for a second. And as I told you before, at this part we're gonna talk about the types of clashes in Navis, or the kinds of clash detections which we got in Navis. But I will tell you the points and techniques later, because we're not going through details. Wait for a second please. To open the Revit file. Well done, the Revit file is prepared. For example, check this out. Here if I select this wall, as you can see here the conflict or clash is clear. If I select the duct, if I select them or hide them, as you can see we got duplicated ducts here, which shows the conflict here. Undo, again I select it, then I hide it. Look at here, select hide. Let me try again. First of all I want to select it, but how do I understand that the object is selected? Let me open properties by this way. Let's check it out. Here if I select the duct, you can see its properties. As you can see, a rectangular duct, but I hide it by using Ctrl+H. Then again I select it, and if I hide it again, the properties will disappear. Anyway, let's talk about the different types of clashes. First of all, I should say that your only way to get access to Clash Detective here it is in Home tab, Clash Detective. I open it to open the window of Clash Detective. I will talk about the details more, but right now I want you to just watch this. Well done, let me maximize the size of window. First of all, I click on Add Test. I will talk about these. You don't have to learn these right now. After that, in Select tab or panel, and I will talk about these items later. I know some of you may not understand the process, but no matter, don't worry. I will explain all of these. Here as you can see, there are types of clashes, hard. Here if I open the drop down list, we got 4 types of clashes. For example, duplicates, searches for mistakes in the models, elements that have been modeled twice, copies and so on. And clearance checks the required minimum distance between 2 items. In other words, it checks the items in which there is not enough offset between them. Clearance is called soft clash. Suppose that you have 2 objects in your project and it should be on a specific distance between these 2. So it's the clearance's job to check the required minimum distance between these 2 items. And we got 2 types of hard clashes. Hard means that, hard checks for intersections between item geometries, just like the intersections between the duct and the beam. And as you can see, we got 2 types of hard clashes, hard and hard conservative. Hard conservative finds potential clashes when geometry does not intersect. For example, when an element contained in another one. When we use hard conservative, it detects the duplicates as well. But I don't recommend you to use hard conservative, since if you want to duplicate items, you can choose duplicate type. And if you want the intersections between the geometries, you can use hard. But when you choose hard conservative as your type, it may find some unnecessary clashes that may not be important in order to make you confused. For example, it may report the doors and windows as a clash in the walls, so it is not oftenly used. So right now let's start from duplicates. All of these 4 types has got points that they need to be told. So please watch this part carefully and don't forget to take notes. And remember that if you want to make money from Navisworks, you should have been mastered in this part of Navis. You can make money by creating animations, by reviewing or making viewpoints, but learning Clash Detective and 4D that I'm gonna talk about it in next sessions. Anyway, I choose duplicates. Here in tolerance, you can specify the range of variation permitted in maintaining a specified standard when designing. For example, if we had copied item with 10 centimeters offset, by the tolerance we can specify to consider this item as a clash or not. So for example, I can specify 0. It means that if the 2 objects were exactly overlapping each other without any offset, it should be considered as a clash. I will exemplify to to clarify these items. So I specify duplicate as type and 0 as tolerance. Then I specify the files for the detection. I choose the whole project. Actually, in the clash detection process, we are always being given some clashes which are not considered as actual clashes. So we need to check the reported items, the given item, so that we should remove the unnecessary ones. And in the continuation, I will talk about all of them. I click on run, check this out. For example, here we got the duplicated items. For example, in clash 1, the door is highlighted. Since we got 2 doors, then we got 2 windows, as you can see, as they are highlighted, and after that the rectangular docked and the another docked, as you can see. So watch this. First of all, as I told you before, we got a duplicated wall as well, which is not recognized in this clash detection. At other places, for example like here, we got 2 similar walls which got intersections of each other, which is not recognized. Or for example, here we got 2 walls that one of them is contained in another one, and this is not recognized as well. But for now, the greatest clash which is not reported here is the wall here, which is not recognized as a clash, since we got 2 copied walls, because here there is a point. Actually, when you paste the walls aligned to the same place, their connection will be different to their lateral walls, so that these 2 walls are not recognized completely or are not reported. But right now, to convey the message better, I want to show the connection between these 2 walls. I extend the wall downward. As you can see, the other one is extended to the end, but the second one is not extended, so that this clash is not recognized as a duplication. So I consider this as a weak point of Navis. Anyway, to make it more comprehensible, I trim these 2 walls by this way, as you can see. I disconnect them from the other walls by this way, as you can see. Let me show it to you in the 3D view. Watch this. So that their conditions are similar to each other. I save the project by this way, and also it will be saved in Navis too, since they are linked. Then in Navis, I click on refresh to update the changes. Then wait for a second to load the changes. I reset the clash detection. Then again, I wanna run the test. Check this out. As you can see, this time the wall is reported and it is recognized. So as a result, I want to tell you that do not rely on Navis that it would surely report the duplicated ones. But note that here we have a specified 0 for the tolerance, which means that the 2 objects should be exactly overlapping each other. But if you agree in Revit, I wanna return the changes by this way. I place them to their previous place and then save. Don't forget to save your project. And then we'll refresh the project in Navis. So just save your project in Revit and then refresh your Navis file. Well done. Actually, the process of loading the changes is not getting done too fast. It's just because I'm pausing the video. But don't forget that it takes some time. I reset the project, but this time I want to specify a new value for the tolerance, for example 20 centimeters. But this time, suppose that I have modified the project units, or let me just modify the linear units in project units. I set it to meters. Well done. This time I want to specify 20 centimeters. Let's check it out, and then let's check the reports. As you can see, the doors and the windows are reported, and then the ducts, both of the ducts. But what is the next one or the last one? This is added to the new detection. As you can see, this is the 2 similar walls, as I told you. But there is a distance between these 2 walls, so that when we specify duplicates for the type and then for the value of tolerance, for example, we specify 20 centimeters, each of the objects which are at the 20 centimeter offset of the other objects are considered to check that whether they are similar or not. So the objects which are placed at the 20 centimeters offset and check that if they are duplicated or not. So as a result, the walls which are different in type, here as I select them, check this out, these 2 walls are different in their thicknesses, so that they are not reported as duplicate. And again, the 2 copied walls which are pasted at the same place are not reported as a clash, since their types are different. I modify the value of tolerance to 1 meter, and as you can see, it got no influence on the clash detection since there are no copied objects in their 1 meter distance. Here in Revit, check this out. I'm gonna give you the last example for the duplicate. Then I got a question for you. Here I copy the wall, and after that paste it here, and as you can see, 1 meter offset between them. Suppose that here we got 2 walls, for example. In other words, we got a 2-layer wall. So just let us check this out. I refresh the project in Navis. And as I told you before, the refreshing process takes a long time, but I pause the video to not waste the time. But as the process of refreshing is getting done, let me give you a point. Note that the material of the walls has got no rule and influence in the application. Only their physical geometry does matter, and their thicknesses actually. For example, the duplicate in brick wall and concrete wall are distinguished in the clash detective. But if there is a difference in their thicknesses, this would not be recognized. The physical geometries should be the same, and their type is not important in the clash detective. Well done. Let me reset the detection. After that, I want to choose duplicates again as type and modify the value of tolerance 1 meter and then run the test. Well done. Let's check it out. For example, here as you can see, so many objects are distinguished. For example, the duplicated items, the walls, doors, ducts, and these 2 doors as you can see. Since we got a duplication here, let me show it to you in Revit. The doors which are in front of each other are reported as a clash. So as a result, this is a very important point that you should take into consideration, that if even there was no intersection or duplicate or overlapping, they would be recognized if you specify 1 meter for the tolerance. That as you can see, the specified type is duplicates and the tolerance is 1 meter. And here I got a question about duplicates type, and then we will go for other parts. As you remember, we had some duplicates in the beams too. I mean, the beams are overlapping each other. Check this out as you can see. But why didn't Navis report these? Why the duplication in the beams and their overlapping was not recognized? The point here is that when you duplicate the concrete elements would join to each other in a way that they are recognized as a single element, so that Navis would recognize them as a single element. Here let me move the concrete beam. Check this out. Here if I press escape, as you can see, they are considered a single object. The elements are joined to each other, and this is a rule and point in concrete elements, so that they would not be recognized as a clash detection in Navis. But if the duplication was in 2 different materials, for example a concrete and metal beam, is going to be recognized or reported as a clash. Well done, let's talk about clearance. So I specify clearance for type. As I told you before, clearance checks the required minimum distance between 2 items, and you specify the distance, the minimum distance in tolerance. So in clearance, the value you specify in tolerance is considered as the minimum offset that is required between 2 items. But what is the function? For example, here there should be a specific distance between the beams and the light, because of some reason, such as the installation of the lights and having access to the lights and so on. Here I wanna select the same type of the lights. I will talk about the other details later. As you can see, I have selected all of the types in the lights by this way. After that, I'm gonna select the same type of the beams by this way, like this way, and other concrete beams. Well done. To consider them in the process of clash detection, and I will talk about this detail, that how can we specify the selections. Then I specify the minimum offset in tolerance, for example 0.5, then I click on run. Check this out, there is no object reported here, since the minimum offset isn't ignored here. Here if I modify the value of tolerance 1 meter, for example, check this out for items, so it means that the required distance is ignored and is not considered. Let's check them out by this way. The highlighted lamps, however, we should change the view to observe them better, so the required offset or distance is not considered in these lamps. Here if I reset the detection, this time I want to check the ducts since they are more important. So here I'm gonna specify the objects. For example, I select the ducts rectangular dots by selecting same type. The offset between the lamps and dots, 0.5 for the tolerance, then run the test. Check this out, we got 10 clashes, almost all of the lamps. That the required distance is not considered, which it means that it is less than 0.5 meters. So in clearance, you specify two types of objects, and then you can specify a value in tolerance. Then it checks the required minimum distance between the two items you have selected. So again, you specify two groups of items or objects here in clearance type, and then the process will be done in your specified tolerance, which is called soft clash as well. That checks the required minimum distance between the two group of items. As I exemplified, for example, we can specify a required distance between the lamps and the rectangular dots, or the, for example, dots and beams and stuff like that you can do them by clearance. And the next type is hard, which checks for intersections between item geometries, and it is the most oftenly used type, unlike hard conservative, since it reports the duplications to you, so it is not oftenly used. And find the potential clashes when geometry does not intersect. Here I'm gonna give you an example. Here let me modify the selection groups or items to apply it on the whole project by this way. I will talk about the standards and the classification here, or clash matrix, or the group of items which are considered in the clash detection process. But right now just focus on the types of the clash detection. Anyway, let's talk about hard conservative. First of all, what is the tolerance here? We talked about it in the duplication, that if you specify 0, it means that the two items should be exactly overlapping each other, and then in clearance I told that the value you specify in tolerance is the minimum required offset. So if the distance is going to be less than the specified value, then it will be reported as a clash. And here if I specify 0.05 is the minimum value which two objects overlapping each other. For example, we got two objects that are exactly parallel and overlap each other slightly at their ends. And here if I specify 5 centimeters, the 5 centimeters overlapping is not going to be reported, since we are not going to face with problems. However, we do not specify 0 for the tolerance. 0 means that a small intersection is going to be reported as a clash, but about 5 centimeters is more serious actually. So 1 centimeter intersection between two objects is not that much important, since it is going to be fixed. So here if I specify 5 centimeters, the intersections below the 5 centimeters are not going to be considered. I run the test. Check this out, we got 72 clashes. Let's check them out. For example, we got an intersection between the column and the ceiling, which is not considered as a clash. So this is the conservative type. But the position of the column is voided and it is joined to the ceiling and there is no problem. Or for example, these two walls, as you can see, which one of them contained in the another one, it is reported as a clash. Or let me check others. As you can see, all of the columns are reported, which are not really clash. Look, they are okay, and the columns does not intersect. But conservative type finds potential clashes, even the doors and walls. So I do not recommend to use hard conservative type. But about hard, it is one of the most useful types, which checks for intersections between item geometry. It displays the actual intersections, not the potential ones. Check this out, these are the 5 centimeter clashes. For example, the pipe is passing through the wall. Check this out. Or we got the intersection between the ducts and beams, as you can see by this way. And as you can see, the intersection is between a single duct and multiple beams. Look. These are the actual intersections. These should be considered. These are not potential clashes. For example, when we get an intersection between the duct and a beam, they should be fixed. They are clashes. They cause problem. So they are reported. So to come to conclusion, and after that I'm going to start our main topic, the techniques, the points which are related to clash detection. Anyway, in the clash detection process, we rarely use hard conservative type, and we use the type hard to check for intersections between item geometry, and we usually set 3 or 5 for the value of tolerance, to not make it that much sensitive since smaller values are solvable as an intersection, so the standard values are 3 or 5. And about clearance, I should say that it checks the required minimum distance between two groups of items, and its second name is soft clash, and duplicates search for mistakes in the models, elements that have been modeled twice, copies and so on. So it is not related to the intersections and the distance. It just corrects your mistakes. By searching for them and report them. So this is all you should know when you rush a clash test. But right now let's talk about the clash detective from the beginning, or the other details that you need them to know to run a clash test. However, I showed you some of them previously. And right now I have talked about the types of clashes, so I remove one of the models. And right now we're just gonna work on this model. So let me remove the duplicates. Well done, and after preparing the model I save it by this way. And following that we'll work on this model. Very well. I refresh the project in Navis. And then I will continue the lesson to teach you everything about running a clash test, such as where to start, the items or objects we should specify them for the standards, and so on from the beginning. Well, if you do agree, I specify shaded and screen lights in order to observe the model better. So as I mentioned before, for launching your clash detection process, at first you should click on Clash Detective. Then the window of Clash Detective will be opened. You may have several clash detection processes in your Navis project. I think always more than 10 processes. For example, beams and ceilings, beams and lamps, beams and docks, docks and docks, pipes and pipes. And about these, I have prepared an Excel file that you will be given, so don't worry about it. And note that when we run a clash test, we specify the group of the elements which are going to be checked or considered in the clash detection process, because some elements are not considered in the clash detection, like walls. And when a pipe passes through the wall, it is not considered as a clash in the real project, since the wall is going to be voided. And we got the same thing with the floor, that the place of the pipes are going to be voided in under the floor, so it is not considered as a clash. And we do not consider walls and floors in the clash detection, so these standards are not necessary in the clash detection process. So as a result, some objects are not engaged in the clash detection process at all. As I mentioned before, walls and floors are not engaged in the clash detection, so that we cannot specify the whole project in the standards for checking the clashes, because we should classify the standards as I told you. For example, beams and ducts, beams and pipes, or ducts and pipes, or ducts and docks. And I will share an Excel file with you that the standards are mentioned in, so that you will be informed with the standards of the clash detection. Anyway, to run a clash test, we should at first open it. After that, I click on Add Test to run a clash test. By this way, check this out. Then the first thing to do is to specify into a group of objects that you want to check for clashes. So I'm gonna say that again, then we do not have comprehensive clash detection or a clash detection for the entire project, because we specify two group of objects as the standards of clash detection. So here I right click to rename it. For example, here one of the most crucial ones is that to check the ducts, for example. So I type duct and their relation with beams. Actually, I'm going to check the clashes between the ducts and beams, or framing, duct and framing, or structural framing. Let me modify its name. Well done. Very well. Following specifying a name, here I want to specify ducts and framings as my standards, so that I should specify or select the ducts in selection A and the structural framing in selection B. So the most important topic for running a clash test here is that to have a correct choice or selection actually. I mean the items which are going to be associated for the selections A and B should be correctly specified. So following that, I want to give you 3 ways and approaches. And if you learn these 3 ways, by the end of the session, you will be almost able to run a clash test in order to have correct selections. And in the continuation, to clarify this topic, I'm gonna create some categories here. Following that, I would explain the 3 ways for you. Then I will explain each of the ways in each of these tests. So I renamed the new test, which I have just added. So I right click, rename. For example, I name it to lighting, and since I'm going to consider the lights of the project with, for example, let me see, lighting and structural framing, for example. Actually, structural framing should be considered with all of the elements. I add one more test, and then one of the most important elements, for example, ducts and ceiling. Don't forget that you should check these intersections with other elements. That the required distance between ducts and ceilings should be considered, which is considered well. Let me check the model in Revit. Then I select one of the ducts to move it down, since we're going to have an intersection, or I can move the pipe. I move down the pipe. Let me modify the value of middle elevation. Check this out. Well done. Right now our project has a clash that is going to be reported by Navis. And for the lighting and structural framing, actually there is no clashes. I refresh the project. Right now I have placed the pipe inside the ceiling, so I should modify the name duct and pipes, not ceilings. But our main topic, which is so time consuming, is to choose correct test criteria. I mean, when we add the tests, the select tab will automatically be displayed to enable us to set up test criteria, and we should set up them correctly. I will continue after saving and refreshing the project in Navis, since Navis and Revit should be linked to each other and be updated. Very well, so how to set up the test criteria in the selection A and B. How to associate, for example, pipes for selection A, and how to associate ducts for selection B, for example. And as I told you, we got 3 ways. So please watch this part carefully. Let me modify the name, pipes and ceiling. Let me start with the first approach, which is my favorite actually, and I normally use this way, and I recommend you to use this way. Here I click on Find Items. As you can see, the window of Find Items is opened. Here you should save selection sets at the number of your categories in your project. But what does it mean? I mean, you should collect all of these structural framing in one category and then save it as a selection set. After that, the ducts. Then save the pipes as the selection set, and so on. But how? First of all, I should specify the category. Here, if I want to choose only the ducts, we can use Find Item tool, as you can see. So what should I specify for the category? So surely ducts. But how can I find ducts? I mean, which of the categories should I select to get access to pipes? I mean ducts. As you know, the category is ducts, but where we can find it? Do you remember it? I want you to remember it absolutely in element. So first of all, I choose element. Then I open the property drop-down list, category. The categories which are equal to ducts. And as you can see in the drop-down list of value, all of the categories are gathered. And we should create selection sets from all of them. However, this process is too time consuming, but if you want to save your time, you can write a script for it. For example, you can use Dynamo. But if you do not know how to work with Dynamo, for example, you can take your time and create selection sets. For example, if I want to specify the structural framings as a selection set, let me see. I open the value drop-down list. Then I choose structural framing. Then I click on Find All. Right now all of them are selected. Then I save the selection set. After that, I assign a name for my selection set. So let me rename it, then I paste its name. Structural framing, finish. Let's go for the next selection sets, which is docs. Let's copy its name before finding them. Find all. Then I click on save selection. I paste the name. Right now our selection set is ready. What else we have? Exactly lighting fixtures. I copy its name, then I click on find all by this way. I save the selection set. I paste the name. Well done. What is the next? Absolutely, ceilings. I copy ceiling, then I click on save selection to save the selection set of ceilings. So before running a clash test, you should create or save selection sets from all of the categories you have in your project. And you want to consider them as your test criteria. And I believe this is the best way for running a clash test. I close the unused windows. Now check this out. The first one is ducts and framings. So I open the drop down list, then I choose sets, and also in selection B. Right now I should choose ducts and structural framings. So by this way you can set up your test criteria. But before that you should prepare your categories by saving the selection sets. And after setting up your test criteria, you specify the type, the tolerance, and then you can run the test. Check this out in a very simple way. And right now the clashes and intersections are reported. So there are 4 intersections between ducts and framings. In other words, 4 instances of the structural framing elements got intersections with ducts. Let's go for lighting and structural framing. First of all, in select tab, modify the test criteria, sets in this way, in both selections. Then I choose lighting fixtures and then the structural framing. Then I specify the type and the tolerance. Let's check it out. There's no clashes as you can see. Well done. Pipes and ceilings. Again, I go through the same way. Or let me say that my way. But I want to introduce 2 another ways. But I do not use them since I think this is the ideal way. However, the another 2 ways has got some advantages. But in compared to the first way, I prefer to use this way. Pipe and ceilings. Actually, I haven't created the selection set of pipes. Again, in find items, elements, category, condition, ceilings. Here I should specify pipes. We have talked about all of these items in the properties. As you remember that when you select an object and then open the properties, let us have a short review. You can find the category in element. So should specify element for the category, then category as the property, then the condition, and after that the value, which is pipes here. By this way, I copy the name, then I save the selection set. By this way, then I paste its name. I press enter. Check this out. In the selection set, it is saved in the selection set. Well done. Let's set up these test criteria, which are pipes and ceilings. Then I run the test. Let's check it out. We got no clashes, which it means that the intersection is less than 5 centimeters. But here we're allowed to reduce the value of tolerance because of the low thickness value of the pipe. For example, 1 centimeters. Again, nothing is reported. Why? Actually, guys, I have paused the video to check for problem. Then I found out that I made a mistake in selecting the ceilings. I mean, the selection sets in lighting fixtures and ceilings are the same, because having no clashes and reports was not normal. So from this mistake, we can learn a lesson that before starting running our test, we should check out our selection sets. By this way, you can just select them and check if the right objects are associated to your selection sets. Since if you make a mistake, then no clashes will be reported. But we were sure that there is absolutely some clashes between pipes and ceilings. And here, as you can see, ceilings is not correctly selected. So I modify my selection set, find all, ceilings, well done. Then I update my ceilings by a right click to modify the selection set. Well done. So in this condition, you can update your selection set. Well done, let's go and well done, everything is okay. Let's adjust the tolerance. 5 centimeters, run clash test, and as you can see, the replaced pipe is reported. Up to this point, we have ran the clash tests between clash groups of ducts and framings, lighting and framing, and pipe and ceiling. I specify them in the test criteria. However, some may want to specify a specific value for the tolerance when running a clash test for each of the clash groups. But normally, we specify 3 to 5 centimeters for the tolerance, and it is acceptable. So our first way for having correct test criteria in selection is creating or saving selection set by using find items, and I think it is the best and ideal way. But what is the second way? For example, if I want to consider ducts and framings as my clash groups, but before that let me add one more test, then I rename it D as duct and F as framing since I want to keep the last tests. So the second way here is that I specify properties for the selection. Here as you can see we got 4 modes: standard, compact, properties and sets, and we got the similar items in selection tree as you can see. So you're already familiar with them. These are the same. So you know them, and if you have forgotten them, I recommend you to watch the video again so that you can remind these items again. Here if I specify properties, then in the subcategories of the element, I choose the category as you can see. So we are looking for ducts, and then I choose ducts. Then for the other side or the selection B element, then the category, and after that the structural framing. By this way, and after specifying the type and the tolerance, I can run the test. But this way has got a positive feature in compared to other ways. Selection sets aren't being updated normally. I mean, if I revise my Revit file and add some more elements to, for example, a structural framing sets, the selection set would not be updated, and it sets up the previous set as the test criteria. But if we use this way, your test criteria is always updated, since it sets up the, for example, structural framings as the test criteria at the moment, so it doesn't need to be updated. So this is the positive feature it has, that your selected items are always updated. But if you are finished with your project and you want to start your clash detection process, this is not the recommended way, since you're at the final stage of your project and you can use find items to just save your selection sets and then run your clash test. But if you're not done with your project, you got so much to do with it, or you're at the beginning of your project and you need your categories to be updated, this is the best and recommended way, because your specified test criteria are being updated with your RVT file, and then you can run your test. So in the second way, we set up our test criteria by specifying property, and after that we specify the category in which the latest changes are applied on your elements. And although this is a good way, to use, but it is just a little bit time consuming. Anyway, but what is the third way? I specify a standard for both the test criteria. The third way is usually used for the small projects, or in other words, in the projects which you want to take a small group of elements into consideration. I mean, you are not dealing with so many objects. And to be honest, I used it while I was talking about the types of the clashes. Suppose that I want to consider the beams and the ducts, or framing and the ducts, as my clash groups. So I select the beam, and then I use the select same type. So I open the drop down list, select same, then I choose same type. Actually, this way has got a negative feature, which is you may have different types of structural framings in your project. So as I told you before, this way is used for limited conditions for small projects. For instance, to run a clash test just in a single level. So by this way, only one type of your structural framing will be considered as the test criteria. Or you should select 2 types and then selecting the same types. So right now, as you can see, I have selected the desired framings, but how can I associate them to the test criteria? By clicking on use current selection, so that only the currently selected objects would be considered for the test criteria, which are assigned for selection A I deselect the objects by this way, then I select the docked. After that, select same type. As you can see, the two docks are selected. Then in selection B, I click on use current selection, so only these two rectangular dots are considered. Then I run the test. Well done, did you get it? Let's have a review about our third way. As I showed you in the third way, in our scene we select the objects, or other ways of selecting elements which I told you before, for example find item or select same or selection sets or whatever you want to select your objects in your scene, and after that you can associate them to the test criteria by clicking on use current selection. Then your selected object will be attached to the selection A and B, and as you know you should do it 2 times for the 2 types of your test criteria, and then you can run your clash test. Well done, we are done with the 3 ways and approaches for running a clash test and also for setting up the test criteria. So please, if you haven't understand the process, I want you to watch the video again, because the main topic, main things that you should know and is required to know while you want to run a clash test, which is setting up your test criteria correctly. In the continuation, let's talk about these icons and check them out. And most of them are useful, and I'm gonna start with select in scene, which is next to use currently selection. But what is select in scene? Actually it is unlike the use currently selection. I mean, when you select or click on select in scene, so it selects your specified test criteria in your scene. I mean, it's objects actually. For example, look at the docks. For example, you want to check that whether all of the structural framing elements are selected or not. So you click on select in scene, and as you can see, all of them are selected. And as you remember, while I was describing the first way, I made a mistake. So I checked this associated object to the selection set by using this tool. I mean, at first I selected ceilings, then I clicked on select in scene, then I saw that the lighting fixtures were highlighted instead of ceilings. So by this way I was aware of my mistake. Thenceforth you can use this tool while you're specifying your test criteria, for example, for checking whether they are specified correctly or not. For example, here none of them is selected, so the test criteria is not specified. I select one of the dots, then I select the same type, then I associate it to the selection B, then I check it out by clicking on select in scene. So it means that these 2 rectangular dots which are selected in the scene are going to be considered in the clash detection. But this tool may not be that much helpful in the big projects, since in the complicated project you may have too many objects which are covering each other. Here we select the elements to be checked. I mean, here we specify the elements which are going to be checked or which are going to be engaged in the clash detection test. For example, the first one is surfaces, which includes surface geometry in the clash test. At a clash test without surfaces does not make sense. So we should always select these, since the geometry of the objects are going to be checked. And the next one is line, which include line geometry in the clash test. You may wonder, okay, what is line? Guys, when we import a file from AutoCAD to Navis, all of the objects are recognized as a line. If I want to clarify it more, suppose that somebody has drawn the pipes in AutoCAD by using lines. Following that, you want to check the lines in your clash detection test in order to find the intersections, so you should check lines. But if you do not select line here, the intersections which are related to the lines are not going to be reported, so you can use it while you are importing a file from AutoCAD. And the next one is points, which include point geometry in the clash test. Same as line, points are exported from AutoCAD too. But note that points and lines are not transferred from Revit to Navis, but only the geometry of your objects are going to be transferred, are going to be exported to Navis, but the points and lines never. And selecting points and lines is not necessary. And about self-intersect. Self-intersect tests the selected geometry against itself for clashes. And actually this is used for the geometries or the objects which got intersections with themselves, for example like stirrups. And we do not consider the self-intersections as a clash. So these elements are not going to be checked in the clash detection test. So guys, up to this point, we have covered all of the tools which are found in the Select tab, which are frightfully crucial to be known. But in the settings part, link and step are left, which are related to the animations, and also the timeliner or 4D simulation, that I will surely talk about them in the next sessions, since I don't want to mix up the topics with each other, since I think some topics need to be explained separately. In the continuation, let's have a short break to practice the given details, the given topic about clash detection test, and you will be given these files, so I want you to get engaged with the clash detection test, and after that we will start the next session. See you.